All right. Welcome, everybody, to the first official session of Hack Central. Unfortunately, since we all can't be together in person and we planned on hosting our first Hack Central a while ago, we're now going to be doing it through online and bringing that experience to your home comfortably. So, so let's begin with some quick introductions of who we are, and then we'll discuss what we want to accomplish through Hack Central and a lot more things. So let's get started. A lot of you guys, looks like we have some people from our Tech Bytes group, but you may know me. My name is Rayaan.
Oh, I joined.
Please make sure that if you're not going to be talking, please be sure to mute your mics, please. All right, thank you. So, as I was saying, my name is Rayaan Siddiqi. I'm going to be a rising senior at James B. Conant High School. I've made a dozen different websites. I've made up multiple apps for the iOS App Store, which you can check out. And I like to write articles, which you can find on my website at RayaanSiddiqi.com. And now my partner, Andrew.
Thank you for the introduction, Rayaan. My name is Andrew Choi. I also am very familiar with coding and programming. I happen to be have an interest in computer graphics. I do code as a hobby. I've even illustrate as a hobby. As for what I am, I'm going to be like a freshman soon at Purdue University. I've made a few projects in my time, just like a Rayaan. So if you want to see them, you can check it out on my website, andrewchoi.info.
Great. So you may have heard us talk about Tech Bytes at the beginning of our session, but here's some of the programs Andrew and I run at the library, which you may be interested in checking out after today's session. The first one being Tech Bytes, where we teach people like you how to code and the importance of computer science, all online and for free.
In addition to that, we have Teen Trivia. Every other Friday, we play a game of trivia online to win gift card prizes. So if you happen to have a night off for the top 5 winners, you can possibly get a prize. Do you know the exact amount, Rayaan? Or
yeah, they range between $10 to $15 gift cards.
Yes, $10 to $15 gift cards, and more than that, we just generally have fun learning about trivia and competing with friends. So be sure to check that out if you're interested.
Great.
All right. So in addition to that, we happen to have Hack the Lib. This is more of a less frequent event. So you will see this not actually July 7th, as that is today. We will have this starting this Wednesday. Is it Tuesday or Wednesday, Rayaan?
The day's wrong. It's Tuesday, July 7th.
Okay, yes. Tuesday, July 8th, correct?
7th.
7th, sorry. Tuesday, July 7th, we are having an online hackathon. It's mostly for high schoolers, although middle schoolers and such can attend as well. So if you have any siblings that happen to know about coding and they want to get engrossed in the competition and the spirit of learning and, well, gaining all that clout for your future applications, that is an excellent idea for you if you can have the time this week. So, yeah.
Yep. It's going to be an online hackathon, guys. You can visit our website at hackthelib.com to find out more information. And there's going to be a lot of cool workshops we're going to be running, guest speakers, and some prizes like Andrew mentioned as well. All right. So now let's get to why we're here today, that being the start of our hack club called Hack Central. Now, what do we want to accomplish through this hack club? Well, we talked about how Andrew and I teach coding topics and programming languages like Python and JavaScript. But through this Hack Central Hack Club program, we want to dive deeper into more advanced topics, which we don't usually cover through Tech Bytes, as Tech Bytes is catered towards a bit more younger audience. And these topics are consequently much cooler and much more fun because there's some more advanced math behind all the topics, and the code is a bit nicer as well. So, yeah. So let's get started. Andrew, you go.
Yeah, so today's topic, you might have heard me preview it a bit earlier when people were asking about it, but today's topic, machine learning, linear regression, particularly linear regression being a part of machine learning. So to begin this, we should probably begin with a question. Anyone know what machine learning or linear regression is? Any general ideas? Any guesses?
It's an open environment. Trying to take anybody have any ideas you want to share?
If you're not fine with saying it publicly, you can always private message one of us, and we will try to conceal your name. Completely fine. We are here to learn. So can we go to the next slide?
Yep. So how about we watch a quick little video, and then Andrew and I will give our thoughts on what we believe machine learning is, and yeah.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. Of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing.
All right. So, yeah. So think about machine learning. It's a huge field, right? And basically what we want you guys to take away is that machine learning is a way for computers to perform tasks without specifically being told to perform that task. Now, Andrew and I, through Tech Bytes, we love providing analogies to real-world examples, and you see machine learning, believe it or not, in your everyday life. Say many of you guys have Instagram, Twitter, and you guys also like to place order items online through services like Amazon and other websites, right? You may or may not notice those same products being advertised to you on your social media platforms like Instagram. You might be scrolling by and you see an ad for, hey, this is the video game I was talking about. What is it doing on my Instagram feed? Well, machine learning is how such is enabled. And Andrew, you talk about some more examples?
Definitely. So, yeah, advertising is probably one of the most prime examples of how machine learning works. And I want you to really notice what the video was saying and how that applies to what the example Rayaan just said. Rayaan is talking about how users have patterns or behaviors that a computer may recognize and then make a prediction based on that data. So in that case, the advertiser sees how you might say scroll through a bunch of feeds on a certain video game. You might look up a video game on a Google search bar, and Google's data may be provided to an advertiser. And the advertiser uses a computer to analyze that data that you put into your computer, and then create a prediction on what you would like, that often being what you just searched. Now, of course, it's not just for advertising. There's stuff like aiding you in your day-to-day tasks. You might have a assistant like Siri or some type of other Google assistant that might suggest to you, hey, you ate this breakfast on, say, every 2 days on the beginning of every month. Let me suggest to you as a sort of breakfast item, when you ask the computer, hey, Siri, what breakfast should I have today? It might just say, go off your previous patterns of what you eat. So that is very much how machine learning works. It looks at your daily patterns, or not just your daily patterns, or patterns of data in general. It'll look at patterns and make predictions. So, yeah.
Yeah. So Andrew hit the nail on the head. That's the key idea. Data allowing an output, and sort of interesting connection to machine learning is what's happening right now throughout the world. Everybody's aware of the whole COVID-19 pandemic going on and how it's affected a lot of people negatively. But a cool thing with computer science and COVID-19 is there's a connection, and that connection is through machine learning. And through machine learning, there are actually ways of how machine learning is able to detect where COVID-19 was started from, the origination, and it's able to detect where are certain points where hotspots of COVID-19 are. And thus, through using machine learning, we are able to slow down the spread of COVID-19. Now, the effectiveness is up for debate, obviously. However, it's still a cool link to see how computer science and machine learning is involved in our everyday lives, even throughout this pandemic, and helping us to stop the spread of this pandemic, which is something really cool. Now, we're going to be talking about today one of the languages which really helps out in machine learning and being able to train a model to make guesses on data sets and to perform a give out value, essentially. And one of the main languages which we utilize in training models is Python. Now, let me take the first point and talk about why do we use Python? Now, some of you are coming from our Tech Bytes session, and you may be like, hey, we've done some code in Python, and we've certainly done some block coding in Python, but this is a bit different code because Python actually allows us to use and implement machine learning algorithms very easily, such as the one which we're going to be covering today, that being linear regression. And the reason why Python is such a great language in utilizing machine learning and implementing it rather than other languages like JavaScript is because of point number 2. Andrew, you talk about that?
Yes, so definitely. With Python, it's what you would call a higher level language. Now, this doesn't mean like it's very astute and you have a bunch of people with like top hats and those monocle glasses, just like higher languages. But it's like, no, Python is just more abstracted. Now, here's what I mean by that. Say you wanted to make a machine learning algorithm for learning, telling apart cats and dogs. Pretty simple algorithm for Python. And the reason why is because you don't have to worry about lower level things. What I mean by lower level is things like, how do you set up the inner workings of AI? How do you set up, how does an AI collect data? How does an AI store data? How does an AI essentially do the dirty work of it? Just processing the data on a very like, we'll say like visceral level. People who write algorithms usually don't need to worry about that. They'll have different methods or common patterns used in libraries such as NumPy, Keras, TensorFlow, and Matplotlib. These take care of some of the data processing for us and allow us to think of how we can use these data processing tools to write algorithms in machine learning. It makes writing algorithms easier.
And later on today, we'll actually see some of these libraries in use as well. So something to look forward to. Now, as we described, we were talking about how machine learning is a huge field. There's classification of cats and dogs, like Andrew was talking about, to all the way to advertisers advertising specific material catered out to your personal needs based on what you were talking about, what your recent search history might consist of. And all in all, it's a huge field. But for today's lesson, we're going to be narrowing it down to one topic. That one topic being
linear regression.
Now, what is linear regression? Well, I'm assuming that a lot of the audience we have today here is in middle school, and this may even, you might know some of the math behind linear regression because it is not as advanced as some other machine learning topics. But basically, linear regression is a way to make predictions given a data set, right? Now, linear regression, we want you to think about it as being a line of best fit using linear algebra and through creating a line of best fit, we can predict values given inputs. So say, for example, we want to predict the price of a car and input a value of how many wheels it has. Well, some correlation which we can draw from that is the more wheels a car has, the higher price is going to be because the more functional that car is. In that same sense, linear regression is used to predict values, not to classify. And as Andrew was talking about in an earlier example was, that cats and dog and a computer being trained upon a data set of cats and dog images being trained to identify, is this animal a dog or is this animal a cat? Linear regression isn't really about that. Linear regression is used to predict values such as in the stock market every day, car prices, phone prices, and more of that prediction side of the world. Now, let's take a look at some of the math behind how linear regression works and how data points are inputted and what values are outputted.
Just 2 minutes.
Right. Yep, so we are good now. So I guess we'll be using the whiteboard which Zoom provides as we have some technical difficulties with the airplay, but that should be fine. So let's talk about the actual math behind this algorithm of linear regression. Basically, we talked about how it's a line of best fit through data points, right? So how about we draw a quick X and Y axis? Mind my drawing. So we got our X and Y axes, and say we have a bunch of data points, right? So say we have this data point, or just right here, right here, right here. And basically how the linear regression algorithm works is that the computer makes a line of best fit through the data. And this line of best fit is used to predict values. So say, for example, that car value of the wheels, the computer generates a line of best fit first, and then say we put in an input of 3 wheels, then this line is used to predict the value of the car. Now, how is this line generated? And what form is this line in? Well, it's a pretty basic form. It's in a slope-intercept form in a line. So it's in y equals mx plus b form, where m is representing the slope. And you want to talk about that?
Definitely. And just so we're clear, it might be a little weird if you're not used to abstractions like y and x, but think of this less like 2 variable relationships and more like 2 examples you might know in your everyday life. X could be, for instance, well, Rayaan said that's one with the tires. How about the amount of hours you do at work? So maybe you have a parent who does like some X amount of hours they spend at work. They have some Y results in how much money their income comes back and they're able to provide for you. For this equation, the way we predict it is that we have a linear equation that we set up using y and x. And keep in mind that x and y vary, but m and b, they do not. They are, for the most part, a constant. And this constant number is achieved by looking at the data set. It's achieved by looking at the numbers that we have in our the large amount of data. And then we run it through some type of a library or some type of algorithm, or your computer, we'll say, and it computes this m and b and allows you to make this relationship.
And how you might ask, how is this line formed and how is the slope determined, right? Well, say we pick one point right here, and we'll pick another data point right here. We'll call this point 1, and this will be our point 2. Well, in order to determine the slope, it's pretty simple. We just find the rate of change, right? So y2 minus y1, the y coordinate over the x coordinates difference. And once that slope has been determined, as Andrew said, that value is going to be the same for the line of best fit, and then we can use it to predict values. So say we'll call this, like Andrew provided, that example of hours worked, right? So this is hours, and we'll call the y, which is being predicted, how much money you make, right? So in order to get that prediction of how much money we make, we use whatever the slope value is, times, say we work 10 hours, plus the y-intercept. We'll say, in this case, is 0, but usually there's a y-intercept. And then through using this, the computer is able to make a prediction of what the total amount of money you should have made, and then we're able to output that. Now, let's relate this to an example which we're going to be going over today. And then we'll hop back on the whiteboard. If we go back on over to our presentation really quickly. All right, can you see my screen, Andrew?
Yeah, I can see your screen. Let's look at math.
So let's talk about a scenario which we're going to be walking you guys through in actual Python. That's going to be, we're going to be predicting the third trimester grades for a student at a university using 5 different attributes. Now, what are these attributes going to be? Well, we're going to look at the first trimester grades of the student, along with the second trimester grades of the student, along with how much time they spend studying, their failures in the classes they take, and the number of absences they have. These will act as the values which we're going to be inputting and training our data set off of, and then a computer will generate a line of best fit in order to predict the third trimester grade of a student. So without any further ado, let's load up the actual script.
Sure.
All right, so here we are. So remember at the beginning of today's lesson how Andrew and I talked about what makes Python such a great language in order to train models and in general perform machine learning algorithms on? Well, it's because of all of these. You might ask, what is this? Well, these are the different libraries and frameworks which we're able to use in order to make our lives easier when training models on data sets. Remember how Andrew and I were talking about import statements in libraries such as NumPy, sklearn, which provides us free data sets, matplotlib, which allows us to make nice looking graphs, which we'll show you guys today, pickle, which allows us to read in data files, and a bunch more. And TensorFlow is a pretty big machine learning framework, which makes it easier to train data sets as well.
Google.
Yep. So we talked about today's example in which we want to predict the grade of a student, right? And we want to see the correlation between variables, such as does having higher absences mean you have a lower grade in a class? Does having more failures in a class mean you'll eventually have a lower grade in a class? Some, although may seem pretty obvious, it's nice to see visually. So I'm not, Andrew, I don't think we're going to go fully into what each line of code does, but we'll just produce through the important ones. Here, essentially, we are reading in our data file. You might ask, hey, how does a data file look like in the first place? Well, if we go right here, I pull up this text file really quickly. We're able to see that this is all the data which we have on students regarding their first trimester grade, their second trimester grade, the failures in their classes, and how well they performed in general. We are able to use Pandas, a library, which we talked about earlier, in order to read that text file. And
If
then
you want a good idea of how this might apply to you, if you've ever filled out a survey from your school or filled out some form to take a test, this is actually where a lot of the data goes. It gets put into some type of long list like the one we've seen.
Yep.
Could you go back to it for a second?
Yeah.
And you'll see that it's a lot like a survey you might take. There's a lot of no's and there's a lot of yeses and there's a lot of numbers. Just think of each line here as a student with some specific properties. So I'm guessing the F means that they're female, right?
Yep.
So there's female, male, age, sex, all of that. So that's how you might recognize that and what you might already know.
Yep. Looks like we got some stuff in the chat. I'm glad you guys are enjoying this. Cool. All right. Yeah, so Andrew provided a perfect example. Think about it when you fill out a Google form, how is that data being sent? And we're able to see that data in a line format of one person, right? Now, this is where we're essentially putting all our attributes, the first semester, trimester grade, the second trimester, third trimester grade, the study time, the failures, and the number of absences a student has. And then I'm assigning the computer what value I want to predict. And it looks like we got some more in the chat. Andrew, you want to take a look?
I'm seeing
Oh, okay.
Sorry, what'd you say?
Oh, nothing. Okay. Everybody's just saying hello. Hello, everybody. There we go. All right. And some more important lines of code I would, go through are this line of code. Actually, is pretty important. This is where we're delegating the difference between training data and testing data. Now, you might ask, what is training and testing data? Well, training data is how we train our computer to output that line of best fit. And testing data is separate. It has to be separate and different from our training data, because if we're going to be testing our computer on the same data on which we trained it on, there's going to be the data is going to be, the prediction essentially is going to be skewed because the computer already knows what, the computer's already trained on that same piece of data, if that makes sense. And here is basically how we're able to delegate how much of the data we want to be split between training and testing data, in this case being 10%. That is what that 0.1 represents.
And if you want a quick analogy, just know that when you take a practice test, it's usually different than the real test.
Yep. Wouldn't really make sense if you knew all the answers beforehand, right? So in that same sense, it wouldn't make sense if the computer already knew all the data beforehand, the same data beforehand, right?
It's different, big difference between memorizing and learning.
And here is where we're using that library called matplotlib in order to make a graph and see the correlation between different variables. So if I run this script,
we'll be able to see that line.
We'll see some sort of graph relating different variables. So here we go. Can everybody see that?
I can't see it.
Oh, because hold up, I'm sharing the wrong. Give me 1 sec. Oh, now we should be good.
Yes, that beautiful data.
Yes, sir. Okay, here we go, guys. So now we can see how our data is correlated, right? we can see in this case, I got the variable absences and comparing that to how does the number of absences you have affect your final grade in a class? Well, we're able to see how if you have an astronomically high number of absences, this student looks like he has 70 some absences. Well, in turn, you're not going to be doing that well in a class, right? However, if we take a look right here, the lower number of absences you have means you have a higher grade in the class. And likewise, we're able to see more connections between different variables. So again, if I change it up, give me one sec. All right, now here's another way which we can see the correlation between variables using our line of best fit, and that being correlating the number of failures you have in a class to how well you do overall in your final third trimester grade. And obviously, we can see that by the data set which it was trained upon and how it was tested upon, that having more failures means that you're usually going to have a lower final grade. All right, and if you remember from Andrew and I, when we were explaining the math behind linear regression and explaining in slope-intercept form, there was that b value, that y-intercept, if you remember y equals mx plus b. Well, we're able to see actually what that b value was, or that y-intercept, in our case as well. So if we run this script, we're able to see that our y-intercept was negative 1.55. So the line would start a bit below the x-axis, considering our origin as at 0, 0. And that is pretty much it for today's first session, in which we talked about linear regression. As always, if you guys have any questions, feel free to leave them in the chat box. We can see that a lot of you guys found today's session very interesting, which we are glad you did. And if you liked it, we would gladly like to have you guys back on for more Hack Central. And we will get back to you on whether we will be doing this bi-weekly or monthly. But in any case, we hope that you guys enjoyed today's session and hopefully learned a couple of cool things regarding the whole field of machine learning, and one specific instance, that being linear regression and how it's used to predict values. And anything else you want to add, Andrew?
I can see that there's some people in the Zoom chat a little disappointed at the length of this lesson and the sparsity of it. But we can, as always, we will make this consistent. Next time, we'll be talking about, to give you a little taste of next time. I believe we're talking about nearest neighbor, Rayaan?
Yeah, we'll be going into a completely different side. So remember how at the beginning of the session we talked about there's regression and there's classification? Well, today we talked about regression and how we can predict values. Well, next time we see you, we're going to be talking about how we can classify data points, such as, say there are different types of cars. Can we classify them into high-level cars, low-level cars, and something of that sort?
Yeah, and remember, just know that there are always online resources that can supplement the downtime we have between the lessons. If you want to learn more about this, we very much do encourage you to go look up that information online. It is a Google search away. So yeah.
All right. So everybody, we hope that you guys had a great weekend, great 4th of July, and be sure to check out our upcoming hackathon if you're interested in more of these similar types of learning more about machine learning, more about different algorithms. You'll be sure to learn a lot of more cooler things at our hackathon called hackthelib.com. And yeah, we'll catch you guys on the next one. See ya.